Chapter 3. And Chapter 3 deals with the derivative, which is given by this, the limit as h goes to 0 of f of x plus h minus f of x all over h. So let's look at what this means. So let's say I get f of x equals x squared plus 2x minus 3. So then the f of x plus h is going to be x plus h squared 2 times x plus h minus 3. And so this is going to be x squared 2hx plus h squared plus 2x plus 2h minus 3. Right. So now let's take what we have and plug it into our definition here. So the limit as h goes to 0, x squared plus 2hx plus h squared plus 2x plus 2h minus 3. So that's the f of x plus h part, minus the f of x part, which is x squared plus 2x minus 3, all divided by h. Well, now we look and we can see that we can simplify the top because we have an x squared minus an x squared, 2x minus 2x, minus 3 minus a minus 3. So those all go away. So we have the limit as h goes to 0 of 2hx plus h squared plus 2h all over h. And then now, of course, we can factor in h out of the top. So h, so this is going to give me 2x plus h plus 2. And now the h's here go away. And so we now have the limit as h goes to 0 of 2x plus h plus 2. And this will just give me 2x plus 2. And we found our derivative. Right? So then the chapter deals with some of the various rules regarding how to find derivatives. And so we have first this. So if f is differentiable at a, then f is continuous at a. So a few of the rules then. So first off, the derivative of a constant is 0. The derivative of x to the n is going to nx to the n minus 1. The derivative of a constant times c times f of x is going to be c times the derivative. Okay. And then the derivative of e to the x is e to the x. So let's look at some examples here. So given that f of x equals 4x cubed, 7x squared minus 8x plus 12. Okay. And so my derivative, well, we take the, so we do 3 times 4 is 12, and drop the exponent by 1. 2 times 7 is 14. Drop the exponent by 1. 1 times the minus 8 is a minus 8. And the derivative of the constant is 0. Right? Now let's look at another one. F of x, 8x to the 4th, 7, the 5th root of x cubed, and 10 over x to the 4th, plus 3. But the first thing we want to do is rewrite it so everything is on the same line. So this is 8x to the 4th. This is 7. The 5th root of x cubed we can rewrite as an exponent. So it'll be x to the 5 thirds. And then we can bring the x up top by changing the exponent to a negative. And now I can find my derivative. So this is going to be 32x cubed. This is going to be 35 over 3x to the 2 thirds minus 40x to the minus 5. All right. So given a question like this, so given y equals 2x squared plus 4x minus 8, I want to find the equation of the tangent line at the point 28. Well, the first thing we want to do is find our derivative, because after all, derivative is going to give us our slope. Right? So we got my derivative is 4x plus 4. And then we want to evaluate that when x is 2. There's going to be 4 times 2 plus 4. So that is 12. Right? So we know the slope. We can now take that and plug it into this, which, if you remember, was your point slope form for an equation of a line. So this is going to be y minus 8 equals 12, x minus 2. This would be 12x minus 24. Bring the 8 over. And we get y equals 12x minus 16. And we got our equation of our tangent line. Right? Well, the thing about derivatives is we can also find higher order derivatives. So if I start out with f of x equals 4x to the 4th minus 7x cubed, I can say, well, I can find the first derivative, 16x cubed minus 21x squared. We could find a second derivative, 48x squared minus 42x. We could find a third derivative, so 96x minus 42. And so probably we could just keep this process going and going and going. You know, eventually we may end up where we end up to 0, like in this one, a couple more times, and my derivative is going to be 0. Right? All right. Other rules you're going to see. So the next one is the product rule. And so the derivative of f of x times g of x is going to be given by f of x. Let me scratch that here. All right. Is going to be f of x times the derivative of g plus the derivative of f times g. Right? So let's look at an example of how this would work. So let's say I'm given this. Y equals 4x cubed plus 7x squared. And the other part is 5x plus e to the x. So I'm going to break this into pieces. So I'm going to say f is going to be the 4x cubed plus 7x squared. G is going to be the 5x plus e to the x. The derivative of f is going to be 12x squared plus 14x. And the derivative of g is 5 plus e to the x. So now I'm going to do is just take all my pieces and plug them in. And so my derivative is going to be 4x cubed, 7x squared, times 5 plus e to the x, plus 12x squared plus 14x, times 5x plus e to the x. And we have our derivative, right? So we have the product rule. And so then the next one is the quotient rule. And so the quotient rule of f of x over g of x. So now this is going to be the g of x times the derivative of f minus f times the derivative of g all over g of x squared. And so let's do an example of this one. And so let's say we have y is 6x to the 5th, 7x to the 4th plus 9 over 2x squared plus 4x plus 3. So again, I'm going to break this into pieces. So 6x to the 5th, 7x to the 4th plus 9 is my f, and then the g is 2x squared plus 4x plus 3. The derivative of the top is 30x to the 4th plus 28x cubed. And then the derivative of the bottom is 4x plus 4. And now we just take all our pieces and we plug in. So my derivative is going to be the g of x times the derivative of f. So 30x to the 4th, 28x cubed, minus f, 6x to the 5th, 7x to the 4th plus 9, times the derivative of the bottom, which was 4x plus 4. All of that over the bottom term squared. And we get that. Let's see. Other one you'll see is they then tell you the derivatives of the trig functions. So we get the trig functions next. And so the derivative of sine is cosine. The derivative of cosine is negative sine. And then the derivative of tangent is secant squared. Okay. So that's my sine, cosine, and tangent. And so now let's do the other ones. And so the derivative of cosecant, hit myself. All right, try it again. So the derivative of cosecant is going to be minus cosecant tangent. The derivative of secant is going to be secant x tan x. And then the derivative of cotangent is going to be minus cosecant squared x. And so those are the trig functions, right? Really, out of any of those, you probably should know off the top of your head would be the derivative of sine and cosine, right? So let's look at an example of a question. So given something like this, y equals e to the 5x sine x. Again, this is product rule. So f is e to the 5x. G is sine x. And then the derivative here is going to be 5e to the 5x. And the derivative here is going to be cosine x. Plug that all into my product rule, and we get e to the 5x cosine x plus 5e to the 5x sine x. Right? Right. Then I do a little bit in terms of some physics application of all this. And so we get, first off, my position. So let's have an example like this. S equals minus 16t squared, 64t plus 32. So that's my position of my object, right? Well, then I can find my derivative. So I can do, well, ds dt is a minus 32t plus 64. Well, it ends up that the change in position with respect to time, well, this is velocity. Right? So my velocity is equal to minus 32t plus 64. Right? Well, then I can take my derivative again. And so dv dt is minus 32. And it ends up that the change in velocity with respect to time, this is acceleration. So now if I'm given something like this, and let's say I want to find the velocity when t is equal to 2. Well, v is going to equal minus 32 times 2 plus 64, and this will be 0. Right? So the barely you got, I took my object and I'm throwing an object up, is what we're doing here. So we're throwing an object up. Is what we're doing here, right? And so in 2 seconds, it's reached, the velocity went down to 0, right? And so that's going to be when it's at its maximum height, right? Right? All right. Right. All right. And so we can say, well, how high is it at that time? And so the height at 2 would be that s is going to be minus 16 times 2 squared, 64 times 2 plus 32. And if we did this all out, it would be 96 feet up. Right? could also ask is, when does the stone hit the ground? And so that will be when the height is 0. So minus 16t squared plus 64t plus 32 would equal 0. And so A would be minus 16, B is 64, C is 32. And so we could plug this all in, and so we would have, well, this is going to be minus 64 plus or minus 64 squared minus 4 times minus 16 times 32 all over 2 times negative 16. Right. So this will give us a minus 64 plus or minus. And let's see, that stuff underneath my radical is 6144 over negative 32. All right. So there's going to be a minus 64 plus or minus, let's see, the square root of that number is, let's call this 78.4. All right, so now what do we get for numbers? Well, let's see. One number would be negative 64 plus 78.4 over negative 32. Well, let's see. That number is not going to make sense because I'm going to a positive number divided by a negative number, and that'd be negative time. We can't have that. So this one doesn't work. So the other one down would be the minus 64 minus 78.4 over minus 32. So what does that give us? And that gives us 4.45 seconds. Right? Okay. And then we can figure out, well, what's the velocity when it does hit the ground? So the velocity when it hits is going to be given by negative 32 times the time. So my velocity function, and we plug this in, and it hits going at a speed of, and this number is in feet per second. The sign here just tells you that it's going down, okay? This is what this really the sign is telling us, right? And then the last rule they talk about in here is the chain rule. And so dy dx is equal to dy du times du dx. So let's look at the example. So y equals 5x plus 4 to the third. So u is going to be 5x plus 4. Du dx is going to be 5. And so this gives me u to the third. And the derivative of this is just going to be 3u squared. And so my derivative is going to be 3 times 5x plus 4 squared, and then we got my du dx times 5. And so we end up with 15 times 5x plus 4 squared. And that will conclude this video.